Okay, in lesson 2 of education, we're going to continue examining the um, relationship between wages and schooling. Okay, so in our model, Patrice, a recent high school graduate, just watched a video on the wage schooling locus. That got Patrice to put some thought into how much education to attain. Patrice learned that the wage schooling locus signifies the connection between education and prospective wages, while the discount rate models a person's inclination towards present over future consumption. Individuals with higher discount rates tend to undervalue future earnings opportunities, leading to a tendency to acquire less education. As such, Patrice is now evaluating the cost and benefits associated with further education to optimize lifetime earnings. The following curve models Patrice's wage schooling locus. According to it, if Patrice graduates high school, Patrice can expect to earn what? So if she graduates high school, this is 12 right here, she can expect to earn that salary right there, right? It's kind of small, so I'm going to copy it. A salary of what is expected if 1 year of college is completed? So if 1 year of college is completed, we're at 13 here, and she's going to earn that amount, right? Blank dollars is expected if 2 years is completed. So 2 years, 1, 2, 14, right there, right? And then if 3 years completed, and then blank dollars if 4 years is completed, right? The salary goes up, but it goes up at a decreasing rate, right? If Patrice earns a master's degree, the salary is expected to be what? There we go. So 18 is the master's degree, right? A year and a half. Okay. So this right here is the wage schooling locus. Now, if high school graduate Patrice gets an additional year of education by completing the first year of college, Patrice's marginal rate of return to school equals what? So what we're going to do here is we're going to calculate. This is, I guess you could say this is schooling, right? And this is the wage. And then this is going to be the marginal rate of return to schooling, right? So this would be 11, 12, 13, all the way out to 18, right? And I'm just going to copy these and paste them right here. This is 12 years of education. That's 13. That's 14. That's 15. Whoops. Okay, and then 16. And then when you're pasting these, and you want to double click so you enter the cell, then it pastes it as text. It strips all the HTML formatting away. And then 18 years of college, right? Now to calculate the marginal rate of return to schooling, what we're going to do is we're going to take the income from the 12 years of education, subtract off what it would have been if they just got 11 years of education, divide by what they would have gotten if they had 11 years of education, and multiply by 100, right? So the marginal rate of return to schooling is this column here, and we need how many decimal places? So we're going to use 0 decimal places for annual income and 2 decimal places for percentages, unless specified otherwise. So let's go back down here, right? So I need to change this to 2 decimal places. Okay. And then I'm going to drag this down. Okay. So completing the first year of college would be 9.454, right? 9.54%. After completing the first year of college, marginal rate of return to schooling is what? After the first year of college, I guess it'd be 801, right? After completing the second year of college, now we're talking about the third year, right? Third year of college, 6.91. Now we got to go to the fourth year, right? 6.06. So after completing the third year of college, she's at, sixth year, right? Or fourth year, right? So 6.06. Okay, now notice that when I enter this in, the graph automatically draws in this red line here. And this red line is at 6.91%, right? That's 6.91% there, right? So if high school graduate Patrice currently has a discount rate of 6.91%, Patrice will attend college to get blank years of education. So she'll attend 3 years of college, right? This is 12 years of grammar school, middle school, and high school. The first year of college, the second year of college, the third year of college, right? So this will be 3 years of education. Well, I guess 15 years, right? 15 total. Yeah, 15 total, right? 3 years of college, 15 years total education. If Curtis and Patrice are identical in all aspects, but their discount rates, and Curtis currently has a discount rate of 8.01%. So this is Curtis up here, and this is Patrice here. Curtis will attend college to get 14 years of education, right? 14 years of education. He'll get 1 year less of education. Okay. Suppose Patrice's and Maya's discount rates are both equal to 6.06%. But Patrice is much more skilled in math and science, resulting in the following differences in the marginal rates of return to education, schedules, and wage school loci, right? So Patrice is the high performer in college. Maya is going to have low math and science skill. So she generally won't do as well in college, right? But they both have the same discount rate, right? Okay. So they both have different wage school loci, right? This is Patrice's, and Maya's is here, right? Underneath it. So Patrice will choose in this model 16 years of education, right? She'll choose 16 years of education. While Maya will choose 12 years of education. As a result, Patrice's annual salary, right? Patrice's annual salary is that value, right? So for Patrice, we got to go up to her income wage schooling loci, right? And use the value of education that she is going to acquire. And so her income is going to be that, right? Well, Maya's, she's only going to get 12 years of education, and she's on the lower wage school and loci. Her income is only 19,500, right? Promoters of higher education use these two values to inform high school graduates that graduating from college boost annual salaries by the difference, right? So this is the high performer in math and science. Whoops, high performer. And this is the low performer, right? The low performer is going to only earn 19,500. And the high performer is going to earn 35,100, right? And then the difference is what high school counselors tout, right? 15,600. That's the difference. Because this is what we observe from college graduates, and this is what we observe from non-college graduates, right? Ignoring the differences in ability overstates the marginal rate of return, right? It's schooling because Patrice, she'd earned that value, right? And we got Ramaya. Double click. If Ermaya only does high school, she makes 19,500. If Patrice only does high school, she'll make $26,162. Why? Because Patrice has greater skill in math and science, right? And those skills tend to be more valuable in the labor market, right? So it makes her more attractive in the labor market if she only graduates from high school. I mean, she's going to more easily graduate from college because she's going to be able to handle the science and the math, right? So this is the real difference. And that's just because Patrice has more skill and ability in terms of math and science, which are highly valued in the labor market. When skills and ability are accounted for, graduating from college increases the future annual salary of a high school graduate by the difference of these two values, right? So this is the high ability worker, right? If this person graduates from high school, that person makes 26,162. If that same person graduates from college, the person will make $35,100, right? The high ability person is going to earn 35,100 out of college and 26,162 out of high school, right? So college doesn't really add $15,600 to a person's annual income if they graduate from college. For a high ability person, it's going to add $9,000 roughly, right? 8,938 in my model, right? Well, the person with lower abilities in math and science going to college is going to do what? So we're going to call this a low A individual. That low A individual is going to make that much money if the person goes to college. And then this much money if they don't go to college and just graduate from high school, right? And that difference is $6,662, right? Okay, so high school students got to be wary of the numbers that their counselors give them because if they have low ability and skill in, say, math and science, then college is going to be very difficult for them. They might not even get through, or they might get through with a very low GPA, or they might major in something that the market salary of that major might be low, right? And so for them going to college, they're only going to add $6,662 to their annual income, right? As opposed to a person with high ability, right, in math and science. If they have high ability in math and science, going to college increases their salary by $8,938, right? Because they're going to end up probably majoring in something that involves math and science. Those kinds of skills are highly sought after in the labor market.